guys, welcome back. So this week we are only doing 2 lessons, so we're going to start off on chapter 8, our new unit. So we're just going to look at the first 2 of these. We are only going to do the Ready, Set, Goes ever while we're doing our remote learning. I'm not going to do one of the lessons with you guys, so all you'll have to worry about is the Ready, Set, Go parts for those of you who are unsure, and just to clarify that for all of you. It is just the Ready, Set, Goes always. So what we're going to be looking at today, like I said, is 8.1. So let's go ahead and get started on that. All right. So what we're looking at here, and let me get my annotate set up. I forgot to do that. Sorry. We're looking at finding the distance between 2 points. So we're going to use the number line to find the distance between given points. The notation AB means the distance between the points A and B. So let me get my little pen all set up. Okay, so if we're looking for number 1, we're going from A, which is at -4, to E, which is at 2. So if we use this number line, now I will tell you, should notice, it's going up by halves each time, so be careful of that. So here's a half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. So that means that to go from A to E, you're going a distance of 6. So obviously for all of these, you can take and just count them out. That's a perfectly acceptable way to do this because we are using the number line. But for most of you, my guess is right off the bat, you're going to think of easier ways rather than having to count it. I will show you how I take and would do these. So for the same one that we just did, we know that A is -4. We know that E is 2. So I'm going to take the absolute value of -4 minus 2, which gives me the absolute value of -6. And so our answer is 6, which is the exact same thing we just got by counting it. Now, the reason I use the absolute value symbols on this is because we're dealing with a distance, but we have a value that's on the negative side of the number line. We can't have a negative distance. That's just not possible. In no circumstances do we ever have a negative distance. If we walk backwards, guess what? We still have a positive distance. It's just going in a backwards direction. Now, yes, when we're thinking about elevation, we can go below sea level and have a negative value, but that's just telling us that we're below sea level. We're below that 0 foot and we're going down. That does not mean we're actually going negative feet. It's just meaning we're going down past what we consider sea level, what we consider the lowest point before we start going underneath that sea level value. So, like I said, there's not a negative distance. So if you get a negative for any one of these first 6, guess what? You did something wrong because we can't have negative values when we're talking about distance, okay? So that's what we're looking at for these first 10 problems is all just about distance. So the first 6 are all based off of the number line. Number 7 is asking you to describe a way to find the distance between the 2 points without counting the spaces. So my example I did for number 1, that would be a perfectly acceptable thing to describe out there. You can describe it in words. You can show it mathematically what you would take and do. Either one's perfectly fine with me. For number 8, you're finding AB. Then you're going to find BC, and then you have to find AC. Now, how might we find AC on this one? We've done this before. You guys had this on your test even, actually. We'd use the Pythagorean theorem. So we have a right triangle. We can use the Pythagorean theorem to take and solve for what the hypotenuse is. So AC is your hypotenuse. So AB and BC, you'll just count it out, and then you'll use the hypotenuse and the Pythagorean theorem to find AC. Alrighty? And then 9 and 10 are just referring back to number 8. And so use number 8 to help you answer 9 and 10. Alright, so let's take a look at the next part. This first part should be pretty easy. All of this should be fairly easy. It's all about distance. And distance is our keyword for this lesson. So make note of that. Distance is our keyword. Whoops. Went way too far. Hang on. Okay, so we're using slope triangles and the distance formula. We're going to kind of figure out how to mix the two together to form our distance formula, because up until now we haven't had a distance formula. We've used our slope triangles on right triangles to find the missing parts, but we're going to develop the formula so that way you don't have to take and always draw out the triangle to figure out you don't always have to do the slope between 2 points first to figure out what the distance is. Okay, so on this, it says triangle ABC is a slope triangle for the line segment AB. So we've got this slope triangle right here. AB is our line segment, where BC is the rise and AC is the run. So remember, rise is the going up and down, run is the going left and right. Notice that the length of segment BC has a corresponding length on the y-axis. So B, it's telling us, is y2 or 8. And the length of AC has a corresponding length. So we've got these values here. We've got y2 and we've got y1. And then for AC, we've got x1 and x2 because these two are both dealing with x values. These two are both dealing with y values because our rise is our vertical. So it's only the y values that are changing. The x value is the run, and it's only dealing with x values. So that's why it's just x1 and x2. And so the slope formula is written as m equals y2 minus y1 over x2 minus x1, where m is the slope. So we know this. We know slope formula. You guys are really, really good at that. You all did excellent on your tests, so that was great. So for part A, whoops, didn't mean to do that. Sorry. For part A, what does the value of y2 minus y1 tell us? So what is that telling us based on what's given in this picture? Well, it's telling us, yes, the rise. So we know that BC represented the rise. So it's telling us the rise. Or what else is it telling us? The distance / length of BC. So by taking the y2 minus the y1, we're finding out the distance or the length of BC. We're also finding out what that rise was from our slope. So for part B, what does the value of x2 minus x1 tell us? Well, if we think about it in terms of the slope, it's telling us the run. Excellent. Or, whoops, make it so you guys can see that, sorry. The run, or what else is it telling us? So just like the last time, it's the distance or the length of length of our AC. So we're getting each of those values by taking and doing this using the y2 minus y1 and the x2 minus x1. This is going to come in handy when we're taking and looking at distance for these. So this question here is kind of the starting point for the next set of questions, okay? All right, so let's go ahead and take a look at that next section. So for this section, it says, in the previous unit, you found the length of a slanted line segment by drawing the slope triangle and then using the Pythagorean theorem on the two sides of the triangle. In this exercise, try to develop a more efficient method of calculating the length of a line segment by using the meaning of y2 minus y1 and x2 minus x1 combined with the Pythagorean theorem. So we're going to combine both the Pythagorean theorem and the slope, sort of, because the y2 minus y1 and the x2 minus x1, that comes from our slope formula. So we're essentially combining these two formulas to take and work through this. So I have the first one, number 12, wrote out on my board here. So we want to find AB. Now A is the point 22 and B was the point 64. So if we're going to try and combine the y2 minus y1 and x2 minus x1 with the Pythagorean theorem, just to keep all these things in mind. Well, if we drew out, not that we want to draw this out, but to help us visualize how this will work. Oops, you guys can't see that. That's a little better. So if we drew out that triangle, the BC part would represent our, which of these two parts? The y2 minus y1 or the x2 minus x1? This one, yeah. And the x2 minus x1 would be this part right down here. So these are our two legs of a right triangle. And remember, the legs of the right triangle are our a squared and b squared. So to write this, we're going to say x2 minus x1 squared plus y2 minus y1 squared equals c squared. So now we have this right here. This is just taking what these two sides are from what we know from what we did in just that last problem and applying it to the Pythagorean theorem. Now, what's the last thing we always do in the Pythagorean theorem? We take the square root because we need to get c all by itself. So take the square root of both sides. That's going to cancel that out. So now we have the equation x2 minus x1 squared plus y2 minus y1 squared equals, and now I'm going to change this c to be d for distance. So this equals distance. So now you have the formula. So any 2 points on the coordinate plane that you're given, you will always be able to take and find the distance between them using this formula right here. So it's a lot of stuff going on in this, obviously. We've got square roots and squares and adding and subtracting and all sorts of things going on. But as long as you follow order of operations, you'll be just fine. So let's actually plug these in and find out the distance or the length of AB. So this is our x1, y1. This is our x2, y2. So if we're starting with x2, we've got the square root of 6 minus 2 squared plus 4 minus 2, because 4 and 2 are our y2 and y1 values. Oops, you guys can't see that. Sorry about that. Hold this up a little higher. Squared equals distance. So now, order of operations. We would do what's inside the parentheses first. So keep our square root. 6 minus 2 is 4. So we have 4 squared plus 4 minus 2 is 2. So we have 2 squared equals our distance. 4 squared is 16. Excellent. 2 squared is 4. Now we add our two values together. So 16 plus 4 is going to give us 20. Now, is 20 a perfect square? Nope, it's not. So this is a perfectly acceptable answer to have. A lot of times with the distance formula, you aren't going to end up with perfect squares. There are going to be all sorts of decimals and craziness as such. So leave them as the square root of the value. So just like this, the square root of 20, leave it just like that. That's going to be a lot easier than taking and having to deal with rounding your answer and finding that big long decimal and then wondering at which point to round it to. So this is the work for taking and doing the distance formula. Now, obviously, there's a lot of stuff going on in there, and it's lengthy when we do it step by step. Now, some of you, I'm sure, will take and combine the subtracting and squaring together. You'll do, what's 6 minus 2? It's 4. 4 squared is 16. So you'll kind of skip this step here is my guess. For some of you, others will want to see each of these steps read out. Sorry about the glare. Goodness. All right. Hopefully there's not too many questions on that right there. All right. So going back to our ready, set, go, and looking at it. So that was for number 12, finding AB. 13, same idea. You're still finding the distance there. Use that distance formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared equals our distance. So use that for each of these. Now, if you notice on 15, it probably looks a little confusing. There aren't any actual numbers. So that means you're going to take each of those letters. Whoops, didn't mean to do that. Sorry. You're going to take each of those letters and figure out, okay, what's my X2? What's my X1? What's my Y2? What's my Y1? Plug it in. Your answer is going to look very, very similar to this, but you're going to have P, Q, J, and K as values in there instead of X2, X1, Y2, Y1, okay? So don't let that freak you out. All right. On to the last part of this, which looks confusing at first, but I promise it's a lot easier than it seems. So what we have here is rectangular coordinates. And so we want to use the given information to fill in the missing coordinates and then find the length of the indicated line segment. So looking at this, we have a few values. So like D is at the X value of 10, which means C is at 10. Oops, sorry, that didn't write very well. So C is at 10, 0. Trying to write these because it's right on the x-axis. And B, it's telling us it's up at 6. And so its x-coordinate, so it'd be 10, 6 for its coordinate. So continuing to fill out those coordinates for each, we know this is 0, 0. It's the origin. So that means this up here is going to be 0, 6. Then this down here is going to be 0, -4. This over here, it's over at -10. Sorry, you can't see me pointing. F is at -10 something. Well, we know that our values down at the bottom are down at a -4. So this will be -10, -4. Should be 4. This one over here, D is 10 something. Well, both of these were at -4, so that means this is also going to be at -4. G, we don't have any values for, but we know that H, G, and F are all at the same X value, so it'll be -10. And then we're on the X-axis, so 0. And then for H, same idea. We're all on the same X-axis, so we're going to be at -10. And then our Y value, just like K and B, we're going to be at 6. So we have all those values on there now. So now for 16A, it says find HB. So from H at -10, 6 to B at 10, 6, how far did we go? Well, -10 minus 10. So -10 minus 10 will give us a -20. Remember to take the absolute value, so that means it just equals +20. And that should be an equal sign, not a less than sign. It just curved weird for some reason. So E equals not less than. So 20 is our answer for that. And then for BD, so we're going from B down to D. So we're going from +6. So this is a vertical, so we're looking at the Y values now. So from +6 down to -4. So 6 minus -4 equals 10. It's already positive, so we don't have to worry about changing the sign at all or taking the absolute value. So our answer for that is 10. So you guys will do the same thing for 17. Fill out, so you've got the second picture down here. Fill it out based on the information given to you, and then answer the questions A and B. All right? So like I had mentioned earlier, your keyword for this lesson is distance, so make sure you get that submitted on Canvas. And so all of this is just dealing about distance, using different ways to find the distance between 2 points and really working with that distance formula that we just learned. Alrighty? All right, happy mathing.